I'm Abby.
I'm Natalie.
And I'm Seon.
And this is the lesson for group assignment.
So, number 1.
Yeah. So, I think this was the lots of math one. Yeah. The constricted pods. So we had to set up a hypothesis for that one.
So, the new hypothesis is the green and then constructed is dominant, and then yellow and inflated are recessive, right?
Yeah.
Yeah.
For the first
We
one.
all were on the same page there.
Yeah. And then the second part, the B, calculate a chi-square value for the data. So our total number of the result is 1,126.
And then we looked at the ratios, right? So what we'd expect, and so we all kind of did it a mildly different way, but it was the same way, just with different, slightly different methods. But so we found that for the first one, the green
Construct.
Anyway, the first one, since those are both dominant, you just take 3/4 times 3/4, and so you get 9/16, and then just going down that list, it would be 9/16, 3/16, 3/16, and 1/16. And then do you want to explain the next part of that one? Okay. Do you want to explain the next part of that one?
Okay, so the expected values, or the green constructed is 916 times 1126, which is 633.375. I kept the decimals.
Yeah.
And the next one is the green inflated 3/16 times also the 1126 is 211.125. Yellow constructed is 3/16 times 1126, which is also same as 211.125. The last one, the yellow inflated, is 116 times 1126, which is 70.375. Okay.
Yeah. Yeah. So that was just, you just do this part again?
Yeah.
Okay. And then, so, let's see what the square root of that.
Okay, so the chi-square is equals to the sum of the observed value subtracted by expected square divided by the expected value. So first one is 562 minus 633.375 squared divided by 633.375.
Yeah, and then just following that pattern with the other numbers, you just continue that
until the last one.
And then
we got a
square root that, right?
Maybe not, because we only need the square value, the chart.
Yeah. Okay, yeah.
So the chi-square value is 43.72.
Which means we reject the null
Yeah.
hypothesis.
So part C, our value is rejected. It means rejected the hypothesis. So we set up the new hypothesis. I got the
Was that was green and
green and inflated are the dominant, and then yellow and constructed is the recessive. Okay.
then for 2, I was talking about the mice and the shaker syndrome, and then the white and black, and it's coloring, and I was talking about what pattern it was, and it's a codominance, meaning that both the colors white and black are present. So then for B, if you do the Punnett squares, you'll see that all the offspring are going to be normal and spotted.
So both black and white.
Yeah, spotted. Okay. White and black.
Okay, and so then
Part C, also the pi square analysis.
You didn't have to have this null hypothesis first, too.
Yeah, they already gave us the hypothesis.
Yeah.
and
So same as number 1, we are getting the total number of the results. And then the rate is from the top, rate is the 3/16, 3/8, 3/16, 1/16, 1/8, 1/16. And then same thing as number 1. We got a Quaskare equation, and then I got a Quag value of 4.77.
I got one of 2.8.
and then I got one of 3.705.
But no matter what, it's
well,
failed to reject.
Yeah,
So-
all three are
so
failed to reject.
We all have work to show, and we all did the same methods. We all have different calculators, so we don't know what happened there, but we didn't really want to do it
Yeah.
again because it took a really long time. But it
Yeah.
should be different. But I mean the general hypothesis
Generally,
is
it
the
shouldn't be
same.
different, but we got a different
Yeah,
value.
the-
But all three of them are rejected to the
Yeah. So there's
valid.
that.
And then for 3, I think we all got
Cha-cha-cha.
different answers for 3.
For 3, yeah. Well, did we?
I did.
Probably. Because for A, well, I mean, I wrote it in scientific notation, but I mean, basically the chance for A was it's not going to happen. But I wrote it as 2.317 times 10 to the negative 4th percent chance of happening.
Yeah.
Okay, so that would
I just
got.
rounded up to the 2.32 and then 10 to the negative 4th.
Cool.
And then B.
We for B we're using the binomial equation, and then I separated the two parts, which is the large grain and then disappear, and then another one is small grain and then non-disappear one. Because I separated differently because they are using different ratio. So, and then I just multiply the two p-values together.
People are loud.
And then I got a 2.64 times 10 to the negative 3.
Sounds good. And then for C,
Oh, I wrote these on the back. That's weird. Okay.
And then for C, because they're using the word or, we're using the sum problem, sum row, and then so 1/4 times 3/4 plus 1/4 times 3/4, which is no, not 3/4. It's 1/4 times 1/4 for the second part, and then it will be just 1/4.
and the answer is just 1/4.
Yeah.
It's just a quarter. Yeah, that's what I got.
For which one?
The
C.
C right here. This
Oh,
one.
small grain cannot disappear. Isn't that the recessive thing?
It's the sum.
Oh yeah.
Yeah,
Just the yeah.
the sum rule. And
Mhm.
then the next one, we're using the product rule.
And I got got 0.00015%.
Percent.
So
I got a
asking for percent.
1.53 times 10 to the negative 6. Because I do the 916 to the 4th times
1.53 times 10 to the whatever.
10 to the, 10 to
Yeah.
the negative 6.
So
How many zeros?
same thing, but I made mine into a percent.
Yeah. Okay.
So same.
Okay. So the next one, number 4, the category. I don't like this for this lesson.
I can do this one a little bit too.
Yeah.
If that's okay. 'Cause I was kind of quiet for a little bit. But
I would just say which
Okay.
what each one
Um,
is.
I can speak fast. So so the first one, we said autosomal dominant, right?
Yep.
Because it doesn't skip any generations, and then it really hits both genders equally. The second one we said Y-linked inheritance because it only affects males, and unlike X-linked recessive, you always see an affected father. And then C, we said autosomal recessive because you skip generations and then you see the genders affected just about equally. Then D, we said X-linked recessive because you only really see the males affected. You only see the males affected. And this one also skips generations. And then E, we said autosomal recessive again because it skips generations and it affects them equally. And then I thought that like bottom center one, they're all affected, and if it was recessive homozygous, then that would be the only option. So yeah, I think that's everything.
For 4.
Oh wait, for 4, right?
Yeah.
Yes.
And then the
For 5,
last
we
part.
Oh right, I forgot about that one because we did it like in the middle.
Yeah. Right here.
You want to just someone just want to read that out, just read it as a paper, I guess.
Yeah, so it's the sum probability rule is used for mutually exclusive events, while the chi-square compares the observed outcome of a genetic cross to what was expected. The second one is more males are affected than females when a trait falls. Is it Y-linked or X-linked? X-linked recessive inheritance, while an affected male produces 100% affected daughters when a trait falls. X-linked dominant inheritance, and then 3 is when calculating probability, the word or indicates that one would use the sum rule. And the fourth one, in probability, the term independent is used to describe events that have no influence on each other. 5 is when a trait falls autosomal recessive inheritance, both males and females are affected with the same frequency, and the trait can skip generations. When a trait falls Y-linked inheritance, affected fathers produce 100% affected sons. For the next one, the sampling error is high when analyzing the inheritance of traits in humans because the reproductive rate is typically low. And for the last one, for the purposes of the chi-square test involving genetics problems, the degrees of freedom equals the number of phenotypic classes minus 1.
Right?
Yep, so that's it.
Okay.
Cool. Well, see you later.
Bye.